All right, good morning. Welcome to the 2019 version of the Orlando Global Azure Bootcamp. First question is, everyone in the back row, are you able to see the screen fine? All right, cool. So we switched out the projectors. When Jared gets here, make sure you all thank him because he brought the new projector. Jared, are you here?
Jared's here somewhere.
Next. Okay, so a huge thank you to all of our sponsors. Please make sure you sign in at the front.
There's a table up here. If you haven't signed in,
Yeah.
sign in sometime before the end of the thing.
So-
Put your name, get some swag.
Right, so when you sign in, you get a few things. You get a sheet.
No. Yeah. Yes.
You get this sheet.
So when so you get a sheet, and that sheet has a bunch of goodies on there. So you get software for free from our sponsors, as listed on these slides. Rev, Debug, and so some of these sponsors also have individual prices, which I will be drawing at the end. So for instance, you might get a JetBrains license or something of that sort if you stay to the end. You should be here when I call your name or your number from your sheet, and that's how you get your prices. I also have the grand prize for today is a Google Home, so make sure you stay till the end. So yeah, so there's plenty of goodies on that. I also have with me these are $80 free Azure account vouchers. Here's the thing. I think if I don't know if these work with existing accounts. I'm pretty sure they don't. But if you have not used, or if you would like to create a new Microsoft Azure account, $80 free. This is as good as an $80 bill, which doesn't exist, but it does now. So
Is it on top of $200 which is given by Microsoft Azure?
I don't know.
That's for you to figure out.
Yeah. If you figure that out, let me know.
We'll let you know.
Yeah. So I will. If you need this, come get them from me, because otherwise, I don't. It's like $80. If you don't need it, I don't want to have to hand it out. So they told me to be judicious with this one, so I will be. So next slide. So a couple of things. Our local sponsors are what makes this possible. This event is run by the board of the Orlando.NET user group, of which I am the president of. So we also do the Orlando Code Camp, which we ran last month, and we do monthly meetups. So we usually do .NET, Microsoft .NET related topics, but often you see cloud-based topics or JavaScript or databases and other things. So please make sure you go to meetup.com/ONETUG as it's listed on there, or you can Google Orlando.NET user group and join our meetup page and show up for our monthly meetups. I mean, our monthly meetups are pretty cool. We usually hold it at a downtown location like Melrose or even Power DMS, which is in the third floor of this building. And after our meetups, we go and hang out at a local eatery, and we serve appetizers. So come join us if you have not before.
Oh, don't forget about the nerd dinner too. We have a nerd dinner.
Oh yeah, we have nerd dinner. So usually every month we have one meetup and one nerd dinner. Nerd dinner is just an occasion where you show up. We may buy appetizers, you hang out and have a nice chat, like all nerds do. So this is a occasion for nerds to be social. The other sponsor for today is Nebbia Technology. I don't know. I also work at Nebbia, so there's a lot of there's a lot of Venn diagram intersections over here too. But any of my Nebbia coworkers show up here? No. All right. So Nebbia is a local shop that's we are about 12 people and focused on Azure and DevOps. So Nebbia is a Microsoft certified partner. We're huge on DevOps. And Nebbia is who bought the bagels and coffee. If you have not had that, the back of the room, there's bagels and coffee. Feel free to go get those. They'll be running out soon. So yeah, and there's plenty of goodies up front thanks to Nebbia. So also make sure you grab those. Next slide. If you need the Wi-Fi password, it's on one of these cards that sits on your table. Can you hold this up?
This one.
Yeah, so it's on these cards that sit on your table, but the Wi-Fi SSID is Starter Studio, and the password is welcome to SS, welcome to Starter Studio, all lowercase. And please don't stream Netflix. I'm already streaming Twitch from here, so yeah, let's not do the Netflix thing. So the next slide, schedule for today. I don't know if you can see this. Are you able to?
Would you mind putting it on presentation mode rather than going slide by slide?
Presentation mode, it's doing the auto stuff. One second.
Just if you do, yes, that's it.
It's presenting.
Yes.
Okay, so yeah, you can probably, so this is how you can tell we have a full schedule, right? You're not even able to see it on normal mode. You have to put it in presentation mode. Ooh. Oh,
It's auto attention.
yeah, can you go back? Okay, so first is Chris. Chris is a Microsoft MVP, and he will be talking about highly scalable web apps. And I'll get to the other one shortly. I should have removed that.
Yeah, the
So you have
transition
some
is
kind of.
Actually, why don't we do this? Well, you just zoom in.
yeah, I'll do it here.
Use the zoom button. We'll figure it out. You know, technologists.
On your right hand
There's
side.
a how many engineers joke over here, by the way. Alright. There you go. Alright, perfect. So next we have Michael. Michael, are you here? Yes, Michael will be talking about Azure Stack HCI, which I'm really looking forward to, by the way. Gabriel, going once, going twice. All right. Hopefully he's here. Otherwise, we'll switch up and with someone else. Around 11:50 to 12:30, we'll do lunch, and hopefully lunch delivery can get here because they're blocking off a bunch of streets due to the parade downtown. So, but lunch is free Subway sandwiches. The choices are ham, turkey, and we have some vegetarian options also. If that doesn't work, there's plenty of eateries around, so feel free to go grab some. Or I can give you some bars I have here. So I didn't put this out for breakfast because I know that some people might want options at lunch. Okay, so can you go to the top again? Okay, so after lunch, we have Hunter. Right here? No? Alright, hopefully he shows up. We'll be talking about text message based chatbots with Azure Lunas. Jared is here, I know he's here. He will be talking about how he connected his old Ford Bronco to the internet with Azure IoT Edge and Azure DevOps, which is a really cool talk. I highly recommend that one. And Justin will be talking about Azure Kubernetes Service. Siva will be talking about Azure ML. And then we'll have the closing down and what you came here for, the Google one. I only have one. I don't have one for RSU, so you got to stay till the end to get it. So, without further ado, I'll get Chris to come and start his talk. So, we'll give it about 5 minutes for him to get set up. So, welcome.
Thank you very much.
You can unplug the HDMI.
This one, right?
I do.
Should probably turn this on. How do you unmute it?
This is unmute.
This
If it is blinking, that's mute.
Okay.
You can type that sides.
Anyone need Azure passes?
I want to test out if this works on top of $200.
Yeah. They have
You try it and let me know.
Yeah, I'll let you know.
How's it going? Do you want to show me how to do it? Or?
Yeah, that's it.
Just stop streaming whenever.
Yeah, it's already started streaming. So it's also coming here.
Give it 1 minute. 1 minute.
It's on It's okay, but they can pay the audience. If you want to like do something, then you can just like
All right. Good morning, everybody.
Good morning.
I get the joy of presenting to you a more alert crowd than if I was later in the day and it might be outside choice. Warm weather, assuming we have here, generally seems to be the case in Florida. So my name is Chris Peachman. So I'm a cloud solution architect. My origins are as a developer. You can find my blog at buildazure.com. I'm a Microsoft MVP with Azure. I've been using Azure for coming on 10 years now, almost. Since end of 2009 or whatever it was with the original pre-release of the service. So I want to get a raise of hands, just who's using Azure today? A little over half, it looks like. Okay. So I'm going to talk about building highly scalable apps and available apps within Azure. So focusing more on kind of the PaaS services, web apps in Azure, some of the capabilities there. Less on the build part of the name of the talk and more on infrastructure. My origins are as a developer. I got more into infrastructure side of things because of the cloud. It's kind of really blurred the lines between. It's good to understand a lot of the infrastructure capabilities behind the things that you have running in the cloud and what's capable before you're trying to build things often. So I want to start out with a question, what are some of the common issues around scalability and availability with your applications? Anybody have any suggestions, things that come up, run against themselves?
Not having enough memory.
Yes. Server resources is an issue.
Synchronizing data, I guess, or state or whatever it is across. If you scale out or something.
Yeah, state management.
Yeah.
Geographic distribution. Geographic distribution.
Geodistribution. Yeah. So, yeah, not being dependent on a single data center, definitely.
Or agile, I guess. Change things around. It's not the same
Yeah,
as buying a server.
the speed of deployment and management, definitely. Yes.
First
Yeah,
thing is standing up the infrastructure itself, right? Which used to take,
yes.
I mean, not
Yeah.
days, sometimes weeks, months.
Getting approval from finance to order the hardware
Out
you
of the
need,
hardware,
and
yeah. That's
waiting
one
6
thing.
months for it to come.
That's one thing.
And on, yeah, definitely. So some kind of highlight a couple areas here that I'm kind of thinking about with the topic areas of the talk here. So servers or instances fail. A lot of times in the older days of on-prem, we would assume we're running the server, we deploy the app to the server, it has 100% uptime, and then when it goes down, we just, as soon as we get it back up, we forget that happened, and we still assume it had 100% uptime. But there are failures, and how do we handle those failures? The cloud lends a lot to be able to handle that more gracefully. Definitely speed of provisioning, as we've mentioned. Bottlenecks or single point of failures like multi-region, multi-data center deployments, or even in a single data center multi-instance. Network latency, so clients being too far away from the server where it's hosted, or even a service that's consuming another service being too far away. Latency adds to the delay in load times and things.
And also add attacks for the availability. DOS attack.
Oh yeah, right. yeah, denial of service attacks, other kinds of things that affect availability. Definitely, there's capabilities built into Azure to kind of detect and mitigate DDoS attacks, which you don't even have, you just automatically get. You don't have to do anything for. Kind of some of those hidden benefits with the cloud. So, kind of looking at on-prem as compared to cloud. A lot of organizations are still moving to the cloud. It's still relatively new. Sometimes I kind of forget that since I've been working mainly in the cloud for a number of years now myself. But yeah, it's often slow to get new hardware servers online. So scalability is slow. Oftentimes you'll over provision or under provision your resources. So you might have purchased extra servers anticipating growth. That growth didn't come. Now you're kind of have that sunk cost, as well as those machines are running, or they're sitting in a closet somewhere. Often only you have a single data center, so whether it's the makeshift data center in your building and all of the issues with that compared to a more enterprise-ready data center being hosted, subject to power failure, internet connection failure, flooding, fires, different things like that. What if that data center has a catastrophic issue like that? How do you manage replicating out to a secondary location? You can do that with colos. Bigger organizations can have multiple locations if they have their own data centers, things like that. The cloud offers a lot more kind of enhanced ability there with the multi-region stuff. Since I'm focusing on PaaS services here, kind of highlight a little bit, like why would you use Azure PaaS services or platform as a service rather than just spinning up VMs? VMs will give you the same you have on-prem, but in the cloud hosted somewhere else. Platform as a service offers the biggest benefit of their managed VMs. So you don't have to manage the operating system updates, the patches, updating, say, the Java or .NET runtimes on those machines, things like that. That'll be done for you. When I say updating .NET or Java, that would be the compatible updating, not moving from incompatible versions. There is some there you have control over managing. But you have many built-in features with PaaS. So we have like built-in load balancing with PaaS services when you scale up multiple instances. There's built-in firewall configurations depending on which PaaS service you have. So like web apps, PaaS service, hosting an application in Azure. So you're going to get requests on port 80, port 443 for HTTP and HTTPS. It's not going to allow, say, 3389 for remote desktop access to those VMs. It's going to be blocked. There's features around multi-instance for manual and automatic scalability, add instances more easily and manage those. And kind of at the heart of the capability of PaaS is really being able to manage more of your applications, not so much the servers and the infrastructure. It kind of gives you more scalability of your teams who are managing your infrastructure. It's kind of a hidden benefit that's kind of hard to quantify at times. So looking at Azure App Service is kind of the marketing name for the service for hosting applications in Azure for web apps, APIs, mobile backends, things like that. You can host apps in Azure App Service with Windows, Linux, or Docker-based hosts. So Windows VM or Linux VM underneath, or there's like container or Docker-based options as well now. Those are actually running a Ubuntu server underneath with Docker on top. This is not Kubernetes, it's not container orchestration yet. There are services for that in Azure, but App Service uses kind of Docker to facilitate some hosting there with its Linux offerings. Then for multi-instance, I mentioned manual and auto scalability with a built-in load balancer. App Service plans are the object within Azure that lets you define what is that virtual machine underneath, right? Everything in the cloud is all virtual machines on the bottom. App Service gives a higher abstraction layer on top of that. We can host multiple apps on the same plan, so essentially they're isolated web apps within Azure, but you can host them on the same app service plan, hosting them on the same VM underneath. So, like an example here, just showing visually, you know, web app 1 and web app 2, they're separate web apps in Azure. We can host them on the same app service plan to share that. The thing with pricing tier for app service ties to the plan. So if you have multiple web apps hosted in the same app service plan, that lets you kind of share cost or share resources to be able to have better resource utilization across your applications. A nice thing with app service is you can move your web apps from one plan to another. So as your load increases on your applications, your business is growing, you know, whatever the circumstances are, you need to scale more. You could scale out your app service plan, adding more CPU memory to it. You could have more instances. Each instance of the app service plan will have an instance of each of the web apps that are hosted in it running. You can also move your web apps out to another app service plan to separate them out or combine them together and move them around on how you need to host them. Yes?
Can you set them up so that if the demand, if you get a spike, it will do it automatically? For
Yeah,
example,
right.
like New Year's Day, Outback Bowl, they have a, depending upon which team wins, they get a free something, okay? And so their website at that point in time is going to set a big time.
Yeah, right. So with the auto scaling feature, you can scale up and add multiple instances automatically. So you can configure that. So based on like CPU utilization of the instances, or the servers underneath rather, it'll add instances to be reactive that way.
Can you set limits as well, not to exceed this amount?
Yeah, you can set what the minimum number of instances are, and then you can set the number of maximum instances so that you fit within a threshold.
Yeah, that's
Generally, you want to have at least 2 instances because you need to design for failure. So if a VM in Azure fails, Azure is going to automatically heal. Not something you have to manage with that service, but your instance will go down if the VM is running on goes down. That could be a hardware failure, or it could be planned maintenance within the Azure data center. So you want at least 2 instances running at all times for normal production applications, but then you can set that auto scale to scale up to 10 under high load, or up to 5, if you set that threshold to. And then when the load drops down again, it'll drop back down to that base of 2 instances.
But that's an alternative to Kubernetes, right?
Different than Kubernetes. So app service, it's more on the lines like you have a server and you have like IIS or Apache hosting your application and you're spinning up multiple instances of that application. Each VM underneath has 1 instance of your app, whereas like Kubernetes with Docker containers, you can spin up 100 containers on the same VM, to more fully utilize resources and do a lot more kind of better orchestration that way of resource utilization. Different model. So mentioning scaling, obviously scaling up, increasing the size of the instances, you can always add more memories, CPU power. Scaling up has to be done manually because that will basically shut down the VM that you're running on and fire up a new one. The way that it orchestrates that with app service is it'll bring up the new one, then take the old one down after the app is running on the new one. And there's a built-in load balancer within app service to load balance between that and manage that. So you can change the pricing tier size without incurring any downtime. It's supposed to be with no downtime. As long as you have 2 or more instances running. With 1 instance, you'll have some downtime there. A lot of times, it can't happen. And then, scaling out, number of instances, which, like I mentioned, you can do manually or have that auto scale feature configured to do it for you. So, say we have an application and we have 3 instances of our app running an app service. There's this built-in load balancer sitting in front of them. So any traffic coming into our application, getting load balanced evenly across those instances. there is session affinity you can configure, so that is an option to be able to use for shared session state if needed. Bottlenecks of performance, so your database or API in the background, could easily become the bottleneck of performance even after you scale up or front end. So being aware of scaling every tier of your application of your system is important. If it's an API, you can increase the number of instances of the API. If it's like a database, it's harder to just add multiple instances of a database, right? You have to set some kind of a replication across instances and manage whether it's single or multi-master for writing data. That'll all kind of vary depending on what database service you're using. Like Azure SQL Database or Azure Cosmos DB have features built in to be able to manage those types of things more easily. So doing things like shared session state, you can use a service like Azure Redis Cache. So Redis Cache is an in-memory key value store. So it's an in-memory database, so it's going to be very fast. It's key value, so you're accessing things. Request the value by the key, it gives you the value back. Save it by key value. It's going to be very fast, optimized that way. It's the same Redis service that you can go download the open source project for and host yourself in your own VM. It's the Redis open source project, but hosted as a PaaS service in Azure. So they manage the VMs and running it, all the infrastructure there, and then you can just use it as a PaaS database as a service in a way. So using that, like if you have multiple instances of your web app and you need to share some kind of session state, if your application uses session state, it's going to be in memory on the server that the instance is running on. That memory is not going to be shared across each instance of your web app, since each web app is going to be running on its own VM underneath. So if you use something like Azure Redis Cache for shared state, you can share that session state across all of those instances. This is something that you would do for within a single region within Azure. Since the speed of Redis Cache, sure, it accesses the key value pairs fast, but it's subject to network latency. So if you have high network latency accessing Redis Cache, it's not really going to be much different than accessing the database directly. First thing, so you'll have the Redis Cache sitting close to your web apps to be able to share for that session state. So multi-region deployments. Azure currently has 54 regions. That's more regions than any other cloud provider. So two of the newest ones they rolled online are the two in South Africa. So Azure is the only cloud to have data centers in Africa. Otherwise, there's plenty of them around the world. A lot of them focused in the US or Europe specifically. When you're choosing the region that you want to use to host your applications, you want to factor in how far is that region from your users, your clients, because traveling across the internet does incur latency. So any communication across a network within a data center is pretty fast, but when you're traversing across the globe, you can add unnecessary latency, unnecessary delay to communications or load times of your application. With the example here, if you have your app running, say West US, and you have users or customers in Canada or other parts of the US, it's going to be relatively fast load times comparatively to having like users in Australia or Asia accessing that same application. They might continually complain of slow performance. Say you're in Florida, you test it, it's fine. You don't really know what they're talking about. Maybe it's the latency across the internet of accessing that server. One thing to note about this image, it's good to visualize, but the actual like fiber connects Australia to the US probably just goes across the Pacific.
Yeah,
So it's like half the distance of what this arrow actually is.
I thought it fell off the edge of that.
Flat Earth, yes. if we colonize Mars or the moon, this will look very different. The moon up here, and then the latency there will be much greater than that. Okay, I'm not sure how the cloud will change to accommodate.
Yes.
So things to consider with latency. You want to host things in the same Azure region. Obviously, it's going to be the fastest communication, the lowest amount of latency, connecting from your app to the database or your REST APIs you have hosted. Another benefit of the Azure regions is, like with pricing, you have costs associated with egress. So any data going out of an Azure region, you pay for the bandwidth for. So if you're communicating within the same region, you don't have to pay for the bandwidth of that communication. If you communicate with an app running in East US, communicating to an app or a database in West US, any data going out of East US, you pay for the bandwidth for, and then when the data goes into West US, ingress, there's no charge. So it could affect the pricing of your solution. Sometimes that's needed with a multi-region deployment, but just be aware of how that impacts. There are region pairs, and these are kind of the better option to use for a secondary region when you're choosing what region to host in. So say East US and West US are region pairs, North Central US, South Central US. There's a distance isolation there between those regions. So if a hurricane takes out East US, that same hurricane will not take out West US. So Azure itself uses those region pairs to fail over in case of a disaster. When there was that storm that kind of took out South Central US, Azure region, Azure did fail over to North Central US. As we remember, there was a huge Azure outage and Azure 80 fell apart and Azure came down. My understanding of that issue, the problem was the amount of resources that were failing over to North Central US simultaneously basically overloaded the data center. And then, so basically the two regions for that same pair came down together. And then there were some other issues where South Central US is used as kind of a main primary region for like Azure AD and other services. Microsoft realized they weren't as resilient to failure as they thought they were. So there were some global impacts with Azure AD, SSO, things like that. Some of the other global services that Microsoft has investigated, researched, figured out solutions, and are working on things to implement within Azure as a whole to help keep those things from happening again. Just kind of some note there on the region pairs. And then other services within Azure that help in regards to multi-region deployments, latency, things like that, are like Azure Traffic Manager, which is a global DNS-based load balancer. So you can have your domain name mapped to your traffic manager, and then that load balances across, say East US, West US, North Europe, to route users to the closest region to them. And then Azure CDN provides a content delivery network that you can use past service. Yes?
Just how does it play with the user with the front door?
Front door? I haven't had a chance to dig into front door too much yet. Front door is kind of more featureful version of Traffic Manager in a way, from the info that I've read on it. Front door is what Microsoft uses for managing multi-region scalability and things with their own services internally. They just kind of made that out as a product now that customers can use.
Yeah, they also do like SSL offloading and other things can be done by the infrastructure up front, so your individual servers don't have to handle it. So let's say you have SSL certificates, you can have them validated as the front door, and you don't have to distribute them on all the servers, because that actual interface itself establishes that's compute intensive resource that gets offloaded up, and it's done at a hardware OL layer 7 level. I think it does all different things with that. So
But it's
Yeah,
also
layer
to
7.
the region that you
no, it's
traffic is coming from.
it does more hardware based instead of doing like software based, has computation for SSL. It will do it hardware based at the layer 7 itself. So that frees up your computation cycles on your individual servers. So it has a whole bunch of features. It also has the WAF, which is the application firewall. So you front door actually offers that also. So you can use that. So it's a very diverse set of features that it offers. So it's basically everything is done at a hardware level. So that's the secret of front door, is it uses hardware to do all of that. So everything is done upfront as soon as it reaches the endpoint, and then after that traffic is done, distributed to the backend servers, and then the backend servers simply handle the requests as opposed to doing all the layers 7 level, like routing and SSL validation and all of that. So,
Yeah, so there's traffic manager just does the load balancing, sending the traffic, HTTP, HTTPS traffic over to the instances, whereas front door does like SSL offloading. There's routing in there, so you can have, based on the domain, like certain paths go to certain instances, certain domains go to certain instances that are routing through the same front door. Other more advanced features than what like Traffic Manager has that are good to have kind of an appliance, like a layer 7 appliance handle for you, rather than every instance handling all of that. So scaling globally, or even like regionally, I mean, data centers fail, regions can fail, servers can fail. Like the cloud is kind of designed to handle failure more easily, handle it better, more gracefully. Designing your applications, you want to design for that failure. Part of the benefit of having lower latency, you have happier users, faster load times. One thing with like the multi-region deployments, a couple of years back there was a big failure with AWS. Their East US data center went down, and there were tons of websites that went down as a result. And kind of the news fallout was like the cloud isn't ready for hosting your applications and services, or you can't trust SaaS services that are hosted on cloud. The reality is they didn't build their infrastructure design properly in the cloud, why they had a failure. They were dependent on S3 storage in AWS within their East US region. That service went down, so any application instance running on that went down. Whether you're in AWS or Azure, multi-region deployment with like Traffic Manager to load balance across regions and things like that, then you can gracefully handle if a region goes down. So like if East US goes down, you have another instance in West US, and you have like Traffic Manager load balancing them in some fashion. Then if East US goes down, the load just shifts over to West US, and you may have 15 to 30 minutes of downtime for some customers, instead of 8 to 12 hours of downtime. Telling your customers, I don't know, it's Amazon's problem. Part of your design can be set up to handle that, and you can use like auto scaling to have like you have your primary and it's handling all of the load. You have it set up to fail over in case of a disaster to the secondary, and you can set up the auto scale on the secondary so it's running with just minimal resources until the load starts getting sent to it, and then it automatically scales up and adds instances. So the cost can be minimized that way. Or you could just have better experience for your users and load balance across both regions to handle them with lower latency. So Azure CDN allows you to set up a content delivery network. So being able to cache static content, so images, documents, CSS, JavaScript, whatever you put in there, static content, to deliver closer to your end users. So there's different pricing tiers to choose with Azure CDN, but basically there's edge locations all around the world. When a user goes to request data from your application, say website's going to load an image, it comes say from blob storage in Azure or directly from the web app itself. it's going to be sent from wherever it's hosted to where the user is. So say that the user's in like London, and the app is hosted in West US Azure region. There's a fairly high amount of latency loading that file across. If you add a CDN in the middle, and you have your client access that image through the CDN endpoint instead, that CDN endpoint is going to, on first load, get the image from where it's hosted at the source, but then it's going to cache it in that edge location. So your server's in West US, your users are in London. When they access the file through the CDN, it's going to access it through an edge location in London to access that file. The first time you'll have the higher latency because it has to go and load the cache. There are ways to preload the cache, but after that first time, it'll have that cached file in there, and then it'll just serve that up directly to lower latency delivery of static content. Azure CDN can host static content that's either hosted in like a storage account that's really static, or it could be even content that's served up from a web application. So your dynamic web application could be sitting behind a CDN endpoint. So the CDN caches the content of that application. At least for stuff that can be cached, right? I mean, if it's specific to user login and certain session state and that, you can't really cache everything. Yeah.
Does the CDN refresh on its own on a regular basis?
It'll cache for up to 72 hours. So after 72 hours, the cache will expire and you'll have to reload the file again.
In the meantime, if the file changes on the server itself,
It doesn't know the file change. When it's cached, it won't know.
It basically
You can
configure
invalidate the cache, you can
TTL.
preload the cache.
You can configure how frequently it has to check if there is update.
Yeah. Yeah.
There is a way to even flush those things, but it is really expensive to have to do that.
Yeah, and then there's, you can do like version URLs, basically with like a query string on the URL for the image, and then you'll have a unique cache for each version that way. So you can handle, if you have a version URL, say for the CSS for your web application, you could version that URL when you publish out the new update, so that your web application starts grabbing the new CSS right away, even if the old version is still cached. Any clients that are still getting served up the old version will still get the old CSS, that type of stuff for handling. So looking at Traffic Manager, it's a DNS-based load balancer. So rather than having to be a proxy where all the traffic funnels into the load balancer and then goes out to the instances and comes back through that route, it works at the DNS level. So like you'll map your domain name to the Traffic Manager endpoint, and then in Traffic Manager you'll set it up and tell it, where are my instances? I'll map my Traffic Manager endpoint to say my instances in West US, my instances in East US, and then I set the load balancing algorithm on how do I want it to determine how to load balance.
Does Traffic Manager do a health checks?
Is it, what do you say?
Health check, like consider now I can configure for
Yes.
Azure East and Azure West, and can I configure, okay, so divert traffic to Azure West only when instance down.
Yeah, Traffic Manager has health probes that get configured in there. That'll basically periodically pings the website and make sure that it's healthy.
Hey, Chris.
Yeah.
If someone asks a question, can you repeat that? Because we are starting to get people
Yes.
on our Twitch stream.
Of course.
Yeah.
Yes, I will do that going forward. So the way Traffic Manager works with it being a DNS-based load balancer is the client goes to access, say buildazure.com, the request comes in goes to Traffic Manager's DNS service because the domain names are mapped. So the buildazure.com is mapped with a CNAME record in DNS, so like buildazure.trafficmanager.net. And then Traffic Manager comes into Azure. Traffic Manager has that backend pool associated with it to know what am I load balancing against. It has the health probe to determine what node or what instances are healthy, what regions are healthy. Based on which ones are healthy and then the algorithm that's chosen. So like performance algorithm will route the user or the client to the instance that's closest to it and in terms of lowest network latency. So user in the US goes to your US instance, Europe goes to Europe instance essentially. The way that it does the performance lookup is it has a lookup table of IP address ranges and network latencies to Azure regions. So it'll know when the request comes in to resolve the DNS name, it'll know the IP address of the client, it'll look it up in that table to know which Azure region is the lowest latency to that client, and then it knows which region to route to based on what endpoints you have load balance. And then there's like failover, so you have primary and secondary failover, and there's a couple different options. The algorithm you use. When Traffic Manager goes and determines which instance to route to, it'll go and send back that DNS resolution to the client. So it's all done on the client requesting what's the IP address of buildazure.com. I want to get the web page for that. Traffic Manager sends back the IP address of the instance that it wants to route that client to. And then that client has the IP address, the DNS name is resolved, it caches that locally or in their ISP caches it. And then when their client connects directly to that instance to download the data. So you have direct connection from the client to the nearest instance to them or to the specific one for failover scenarios.
How can I control how long that DNS application should be cached? Like, for example, now Traffic Manager resolved and gave me a DNS list.
I forget what, the cache time, or what is the cache time for the DNS resolution? I forget what the browser's timeout threshold is there. And I know ISPs can kind of get in the way because, I mean, your computer connects to your router, which connects to your ISP, which connects to their ISP as far as, the hops go for DNS.
That's the purpose I'm saying is like consider I have a traffic manager to avoid the handle the failover. But if I say after the DNS resolution done, then the data center is down.
Yeah, so what happens if the data center goes down after the DNS resolution is done and it's being cached? You have to wait for the timeout essentially. There is, like the health probes run periodically. I forget exactly what the timer threshold is on when the health probes run.
Correct, but even
But
if the health
you can
probe-
have like a 15-minute delay when an instance goes down before Traffic Manager reroutes traffic and the client actually sees that route change to the new instance. I've seen it can be like a 15-minute delay at times. So, like when I gave the example of like the Azure region going down and then failing over to the other region and having, say 15, 30 minutes of downtime versus waiting for Azure to come up again, that's kind of where that time of downtime actually kind of comes from the Traffic Manager. If you're using that, there's going to be some delay, but it's going to be minimized.
So do I need to pay extra money if I have to have the time less? Like probably that means I'm hitting the traffic manager more frequently. Instead of 15 minutes that I configure for
No, the client will do the DNS resolution as it does it. There's no extra charge for the DNS resolution piece.
So traffic manager is kind of free.
It's not, well, it's not free. I would have to look at the pricing tiers again to see exactly what the cost looks like. I forget the specifics to give you details there. So with Azure Regions and Traffic Manager, Azure DNS services like that, these are global services within Azure. They don't exist within a single Azure region. So like you provision Traffic Manager in Azure, it resides just in Azure, kind of within the cloud, not within a specific Azure region. So it's resilient to an Azure region going down. So if you set up Traffic Manager to load balance, you can load balance against an instance in Azure and AWS, on-prem, Google, wherever, with the same Traffic Manager instance. And as long as Azure is running, that Traffic Manager will function and your load balancing will work. It's not region specific. And hopefully if there's a regional disaster with South Central US, we won't have it take down Azure again. now that Microsoft's learned how to be more resilient to failure. I want to just show in the Azure portal a little bit to kind of see what some of the things look like. It's kind of hard to show actually doing infrastructure stuff within the portal. We're talking about features. I wanted to show a little bit. So this is an app service plan that I have running. So it shows the instance size there. Scale up, we can show the actual instance sizes. So right now I have this one running with a standard S1 size instance tier. Basically it's a single CPU, I believe, 100 total ACUs. So Azure compute units or ACUs are used to kind of tell you the performance. So you can easily compare the pricing tiers' performance to each other. There's some documentation on the Azure docs to what does 100 ACUs mean? How does it compare between like app service and VMs? You know that. But then I have 1.75 gig of memory with this specific tier that I'm using. If I go to scale out, I can see on this specific app service plan right now I have one instance. I could drag the slider over and hit save to manually scale multiple instances. And then that essentially scales out multiple instances of the VM underneath, and my app is running one instance of my app on each of those VMs as far as what apps I have hosted within the plan. If I click enable auto scale in here, I can go configure the rules for auto scaling. So I can say when the average CPU utilization across all of the instances in my plan reaches, say, above 70%, I want to add one instance or add 5 instances, or I could tell add 30% more instances. Different configurations like that. You can do that based on like memory utilization, the HTTP request queue, things like that. And then you can do the other way as well. You got to set up scale out and scale in rules. So scale out instances, adding, and then also the similar rules. So maybe CPU utilization threshold maybe drops below 40%, and I want to remove one instance. And you can see there's boxes here for minimum and maximum. So you can set the minimum number of instances. I don't want to go below, say, 2 instances or one. You're not going to go below 1 instance, but if I don't want to go below 2 or 3 instances, because I know I normally need that for the load I have. And then I don't want to go above whatever the maximum. So I want to control cost. I don't want to ever go up to 10 instances. I want to control max of 5. And then the default is just the number of instances that it'll automatically set when you hit save before the scaling rules kick in.
I have a question.
Yes?
How does it set the default size? Like, is there always a single size default, or depending on the size of the service you design, will the default adjust accordingly?
So the question is, how does it set the default? So that when you first create an app, it'll have one instance. Initially, just the one instance without any scaling configured. When you configure the auto scale, you can configure the, like I mentioned, the minimum, maximum, and then that default. That default lets you say, when I save my auto scaling, I want it to scale up to a maximum of 5 and then down to a minimum of 1. However, right now, I want to make sure that I still have 3 because I have load under this application as I'm currently configuring auto scaling. So then I would set 3 for my default, and then when I save that, it'll automatically scale up to 3 if I don't have 3 running. And then after, say 5 minutes or 50, whatever the timeout threshold is there, it'll start applying the scaling rules and then scale up or down accordingly.
So you manually set the default as well?
Yeah, the default is kind of a bad name here. It's the default, like how many instances you want it running right now when you save the setting, but then after that your rules will take over. It's not really a default for the service.
It is something like a pre-warm instance. Like consider when I'm deploying itself, I want the 3 instances.
Yeah, it's kind of like pre-warmed instances. Yeah, you want to make sure you have those number of instances right now. So if I click on apps for the plan, I can see I have 2 web apps in here. So those are separate web apps. Each web app is hosted in its own isolated sandbox from anything else. They can't access the files of each other.
And you mentioned in one plan I can have a multiple apps,
Yes.
and if I so every app will be run on its own instance, or I can configure 2 apps run on the same instance.
No, the app service plan equates to the instances. So the plan is kind of like the VM, or the set of VMs for multi-instance. And then each app you have hosted in that plan will have an instance of that app on each of the servers in the plan.
So it's one. So you have one application has to be one separate plan.
No. So
So if can I say like I'm running 2 websites from a single machine, a single VM? If I put like 2 apps in a single plan.
yeah, so like having like 2 or more websites in the same VM, that's the same as having 2 or more web apps within the same app service plan. So like the app service plan is like the VM, and then the web app is like the actual application hosted in IIS.
Okay. So that means when I am auto scaling up or down, that whole setup, like consider if 2
Yes.
applications are running, it will be repeated.
Yeah, scaling up and down. If you add instances, it increases the number of instances of VMs, so whatever apps are in that plan will also scale with it. And then there's, like I mentioned, there's built-in load balancers to be able to load balance across those instances that does health checks to make sure they're healthy. If one goes down, it'll spin a new one up to make sure it matches the threshold we have configured. So like if I go to one of the apps here, I can see this app, it's in a running state. You can stop the app, you still pay for the plan. Just depends whether your app is up and it's available or not. Each app has its own URL, its own, you go down to like configuration, its own app settings, connection strings and things that can be configured. So, and then it runs in its own sandbox. So like each app can't access the files of another app that are running in the same plan. So it's more of a sandbox, isolated environment than what you would get with just running multiple apps in the same Apache or IIS instance.
So like create a container, right? So that's what you run in the backend.
So
Focus on that, on the application. That
yeah,
way.
the question was the container. Yeah, you focus on the application, deploying your application code, not managing the infrastructure. Underneath, it depends. Like the app service running on Windows is a Windows Server VM with IIS or Apache installed on it underneath. The Linux or Docker container options are Ubuntu server with Docker running on it, and then your app runs in a Docker container, and that's how it provides the isolation. With the Windows host, Microsoft kind of built their own isolated sandbox environment. It kind of stems from stuff that they built in the origins of Azure.
Do you think they are shifting to the container paradigm instead of application based? I mean, based on the compatibility with other clouds.
So are they kind of shifting more to containers?
Yeah.
So Docker, Kubernetes.
Because I say it's the
support?
same thing what you're saying, but it's focused on the on applications instead of containers or whatever it lives inside.
Yes. So the general direction of where Microsoft is going with services, PaaS services specifically in Azure, are containers. They've basically been doubling down on Kubernetes and Docker with everything. There's like the Linux support with app service runs on containers underneath. You can actually, with the Docker container support with web apps, you can take your own container and host it in web apps. You don't get you get multi-instance auto scaling, whatever that app service provides, but it's not like Kubernetes orchestration. And then there's like Azure container instances where you can run one-off containers there as well. And then there's also the like Azure Kubernetes service and things where you get full orchestration with Kubernetes on top of using Docker containers. There's a lot of container support that they're adding into Azure. it'll definitely get interesting to see how it affects like Azure App Service versus
Yeah.
container options within Azure. App Service is neat as a PaaS service for hosting web apps. The Linux and Docker support for it, I think, is a natural kind of progression to be able to, one, support Linux, which they didn't before, but also being container-based, I'm sure lightens the load on kind of what they have to build and maintain for that sandbox environment. But you don't have that orchestration. So if you're building microservices, container-based deployments, things like that, then you're probably going to lean more towards like Azure Kubernetes Service to host instead. And I know they're adding more container support to Windows, so I'm kind of curious myself on how the Windows hosting of App Service will go in the future, if that'll be adopted more containers underneath. But there's Kubernetes and containers are definitely being added to like everything and being fully embraced by Microsoft and the stuff that they're doing. There's a little bit of redundancy in a way, but it kind of serves different purposes. Like if you're hosting a web app, you need multi-instance to host it, auto-scaling, those types of features. You have it with App Service, and then with like Azure Kubernetes Service, you have full orchestration as a PaaS service with Kubernetes to be able to host Docker containers. And then if you're doing, you host your web app there, multi-instance, or if you're doing like microservices and scaling out that way, you kind of have the service that fits your need there. Scaling App Service, you have one instance of your web app per instance of the App Service plan, which you have posted there. So you could be over provisioning with App Service if your app's not fully utilizing the VM it's running on. Whereas like Kubernetes, you can tell Kubernetes, with Docker, you can tell it, I want this container to use 0.3 CPUs and this much memory, and then I want to scale out to 1,000 instances on my cluster of 5 nodes, and then essentially be able to fully utilize the resources that you're paying for. So it's a very different model that lends itself very well to microservices, whereas like App Service, you can still do microservices, but it's a little bit more focused on like hosting web applications. So a little bit different model.
As part
Yes.
of the orchestration, do you also get a portal where you can see all your YAML configurations for the Docker orchestration?
Now with App Service, App Service doesn't provide the orchestration like what Kubernetes does. It's more, I have a Docker container, I'm running it on this instance of a server, and I want to create multiple instances, it spins up multiple servers with that container running on it. If I host multiple web apps in the same App Service plan, that gives me the ability to put multiple applications in the same VM, but it's not going to run multiple instances of the same app on the same VM. That's something that you can do with Kubernetes.
This is more like an application oriented. The focus is on the application, so you don't get the fine grain of what running inside compared to what you have when you're doing microservices. That you have a node, and inside of that node you can have, maybe a few containers that they all work together. So you don't have that fine grain in here. This is application
App
focused.
Service, you don't have such the fine-grained control of
This
of
is application
infrastructure.
focused.
It's abstracting out the infrastructure. That's the
Yep.
main goal of it.
Yeah.
And you can focus on your app code and deploying your app and your app configuration
Yep.
and just managing the minimal pieces that you need there.
Yeah, I see app services as you have small and middle tier apps. You want quick, you want easy, you want a UI. That's the way to go. You have something complicated. There's no real UI with Kubernetes. You're fully script based. You have complete power, but the learning curve is
Hosting applications will be easier with web apps, but then you have it really is kind of that level of control. Like first you go to web apps. If you can use web apps, great. If there's something you can't do there that you're trying to do, then you move to like Kubernetes or just a straight VM to have that power control.
Having the IaaS, you control everything. You go in the middle, like you have a control part of it. And you go to the other side, which is Kubernetes, which is not
The level of control is
rebuild your application to microservices.
there's different degrees of control. Definitely, you kind of going from PaaS to more container based to full VM infrastructure. Definitely giving the full control. So, all right. Thank you. So,
Yep.
my blog, buildazure.com. You can follow me there. I also have a weekly newsletter that I do. So Build Azure Weekly goes out at the beginning of every week. It's a linked digest of all of the Azure service releases, news, blog articles, videos, podcasts, and things for the week. You can go buildazure.com and subscribe to that. If you have other questions, feel free to email me at chris@buildazure.com or contact me on Twitter @buildazure.
Thank you.
Can you turn it around a little bit?
Yeah, I saw her like
You need to straighten it out.
together. I can't wait. Which that would have break with the fall then.
Yeah.
Okay.
You need to move on.
Yes, I think I said, yeah, I get SharePoint.
Yeah, that's
That the thinner guy.
yeah, I will add.
Who's coming.
They has a picture.
Yeah, the bigger.
Can you make that?
Go ahead.
Yeah.
All right. Good morning. Welcome to Global Azure Bootcamp again. So I'm here from Microsoft. My name is Michael Godfrey. I am a premier field engineer with Microsoft. I specialize in Azure infrastructure and private cloud infrastructure. So that would be your software-defined data center, the stuff you guys are running your apps on. So I'm getting the feeling I'm amongst a lot of developers. Is that correct? Yeah? You guys are all in VS Code and Visual Studio, and I'm over here in PowerShell. So I am one of the guys that you guys toss your code over and say, can you make this actually run? I set up the networking, the storage, and the compute for that stuff to run. And so what I wanted to talk to you guys about today is Azure Stack. We initially titled this Azure Stack HCI, but I'm actually going to go into both versions of Azure Stack. So we have a couple trends in the IT industry. We're seeing a lot in the infrastructure space of going to this thing called hyper-converged infrastructure. How many of you guys know what HCI is? Okay, 1, 2, all right. So what HCI is taking your Hyper-V, or if you're a VMware shop, VMware ESXi host, and combining the storage that used to be on a SAN appliance through fiber channel or whatever into that. So we're taking local hard drives that are on those Hyper-V or ESX hosts and making software-defined storage out of them. We may even go the next step and start doing software-defined networking, where we're building some virtual machines to do network controlling and create a microservice of the networking that our containers or our virtual machines would need to be hosted on these physical server nodes that are being our virtualized host, right? The other thing is application innovation. We've seen a lot of movement in application innovation to go with the use of containers and the tools that go with it. Azure Kubernetes services, Google's Kubernetes services that they started, all these things combined with containers are kind of fueling a modernization that Microsoft's seeing across the board. The other thing we're seeing is hybrid cloud. This is the answer that Microsoft is calling to that no other cloud is providing, right? Microsoft definitely sees that private cloud is a huge function of your data centers. You guys have data centers, you have sunk cost with that physical hardware and everything you've spent on those data centers, and it may not be financially responsible of your company just to throw things into the public cloud. So Microsoft has really focused on hybrid cloud, and that's where Azure Stack really comes into the play. So what are the reasons to go hybrid? It's mostly to meet your needs of your user teams and users to speed up your software development. With private cloud, we can easily develop your apps on premises in Azure Stack and then single lift and shift those up to the public cloud in Azure, AWS, or Google without any code changes, really. And that's what's brilliant about this whole process is your developers can develop one time and just lift it up into a public cloud of their choice. Right? You already have that sunk cost of your data center, so why not put some hardware in there that your developers can use, that you guys can use all together. It allows us to also back up data to the cloud. With infrastructure, we do have to have a large storage array just for backup of the virtual machines, and that doesn't make a lot of sense. Why not send that backup where it's cheaper to store it and where there's no data happening in? So we can send that up to a cloud service provider like Azure. Things like remote services to give us CDN and traffic manager and other features that you've heard about in the Azure App Services, we can actually apply to infrastructure services on premises as well through Azure in the backbone. And this is also to reduce your data center footprint. As your managers and C-level executives are looking to replace hardware in your existing data center, they're starting to think, why buy it in the first place? And so we need to link things that are in your data center to things that are in the cloud data center as well. So the approach is to bring consistent cloud services brought on-prem while giving you connected services from your on-prem to the cloud and making those seamless, right? There are challenges though with hybrid. You've got things like identity. Where does identity fit into this? Do you use identity as a service through Azure Active Directory? Or do you host your Active Directory on premises? Or do you link the two together and use a combination of Azure Active Directory with your traditional Active Directory on premises? How does that RBAC fit in? How does auditing and compliance and things like PCI compliance and things like that go? What do you use to manage all these tools and monitor it? You need a single pane of glass to monitor your infrastructure on-prem and your infrastructure that's running in Azure or Google or Amazon. And tracking that usage. I've heard a lot of you guys say Azure's great, but it's really expensive today, just overhearing, and yeah, it can be. But you've got to realize that Azure has a lot of tools built in it to help you keep that cost under control. One I won't go into today, but is Azure Advisor, really. And that helps you understand. How many companies will tell you, you're actually not using all the memory that you've got in this virtual machine. If you dropped it, you would save, $60 a month by going to this virtual machine. and then migrating your apps or data with things like Azure Site Recovery. So we have tools like Azure Site Recovery for lifting and shifting full-on virtual machines and databases up to Azure, or we have tools like Azure Migrate. Azure Migrate will actually look into your virtual machines, see the applications, and see if we can strip them out and make them to a container or a platform as a service application, and help you transition that into that function. So we can help you move your databases from a SQL server on-prem to a database as a service running in Azure. We can help you move it to a infrastructure as a service virtual machine running in Azure with SQL installed. And then save you on the licensing with that through things like hybrid use benefit. Make sense? So we have 3 main platforms when it comes, and I know it's really hard to see for you guys in the back. Santosh, can I email you the deck and have you spread it? Okay.
Yeah, so after this event, I'll get the decks or code samples, and I'll probably put it up on the ONETUG GitHub repo. So you should be able to download it from there.
Cool. So there are 3 main solutions when it comes to Microsoft's hybrid cloud approach. We have Azure, which you're used to, and that's the public cloud. Everything you have, 54 data centers. There's actually more that I just can't talk about. Sorry. And then there's Azure Stack and Azure Stack HCI, and that's what we're going to dive into. But really, there are 3 main things that you're going to use them for. So what would you use Azure for? That's what you're going to use the Azure portal for: platform as a service, infrastructure as a service, and cloud platform tools that you want hosted completely in a public cloud. Azure Stack is a solution of, I want Azure and all the power of Azure, but I don't want to have it leave my data center. So Azure Stack is a collection of hardware that Dell or HP or Cisco will bring in, install, give you the keys to, and you can install your applications as a developer in the same application services that you would on Azure, just on premises. It's all hosted on-prem, and everything is exactly the same. The same portal that you would be used to, but now your administrators have a little more control because they're running the update cycle and they're running the feature cycle in that. There is some cost associated with that, so you don't get completely out of the compute and application spend processes that you would in Azure, but it's reduced costs. We also use Azure Stack for disconnected scenarios. So I've had a lot of cruise ship companies start to use this. They want to host containers and cloud-based applications, but they don't have the latency to handle it. So they deploy an Azure Stack solution on the ship itself. And in the intranet of that ship, they still have cloud-based applications, just without the internet connection. Right? Azure Stack HCI is a brand new solution that was announced last month. And Azure Stack HCI is for your legacy applications and legacy infrastructure services. Things that don't make sense to bring up to the cloud, right? You may have an app in a database server that cannot be separated for whatever reason, they can't be containerized for any reason. We can host that in your private cloud data center with Azure Stack HCI. And you get features of Azure and the backbone of what Azure is built on. Everything that is included in Windows Server 2019 is the same level of what they use in Azure. So Azure uses Hyper-V for those virtual machines. We use Storage Spaces Direct, which is a software-defined storage technology. And we use software-defined networking version 2 that's built in to Server 2019. All these features are in the Azure Data Center and Azure Stack, but we're now exposing it to you through Windows Server 2019. So Azure Stack HCI is a collection of those, and we'll dive into that. So Azure Stack, this is that product that is meant to be at the edge and disconnected. It meets all your regulatory compliances, and it helps you modernize your legacy systems, right? So some scenarios that we see with Azure Stack, and sorry this is kind of salesy, but I don't know how much of a demo I can do. Financial services, retail, manufacturing, public sector, they all use it for different things. Retail, I've seen it using for inventory and ordering systems on premises. So I have a large retail customer that does department stores, and we're using Azure Stack just in case the stores will lose connection to the data center. They can still operate completely independently, and it keeps the bottom line of the cash registers are running, right? a large grocery store that you guys are used to is going this route too, with the big green P store. Financial services, we see it in the banking industry quite a bit. So we're deploying Azure Stack to the branch locations and then having Azure services in public cloud, and those two are talking together. And then you heard me mention about cruise ships. So some good examples of where you would use Azure Stack. It is a complete extension of Azure. So everything that we're developing in the Azure public cloud is actually being pushed down to Azure Stack through these updates that come, I believe they come in every 2 to 3 weeks. And so all the services that are available in Azure, for the most part, it's like 98% are available in an Azure Stack deployment. And it gives you a purpose-built integrated system.
One question.
Yeah.
You mean that you have to acquire new hardware, or you can use existing?
You have to acquire new hardware. Yeah. There is a dev kit that you can run on your own hardware, but that would not be for production, right? And the dev kit will allow you to run in virtual machines, so you can test it and see how it operates.
So how does the model looks like? Are we talking about having that deployed in any of our on-prem data centers?
Mhm.
Where we
Yeah. So you can, I'll get there. Your Azure Stack deployment, you can deploy anywhere you want it. So you can deploy it in your data center and have your developers develop apps one time on that Azure Stack, host it in your intranet, and then if you feel it's ready to go out to the world, you can literally migrate that application directly up to Azure.
Like having a e-blocks
Basically.
hardware with the Azure software.
Exactly. Same portal you're used to, same PowerShell, same REST API, all that just hosted on premises.
what do we need to get started with? Maybe kind of a range of VMs to start with?
Well, the Azure Stack has everything you need into it. And so when, let's just use Dell as an example, I'm not picking on Dell. When they deploy it, they will literally install everything and give your administrators the key to the portal, and then they can start setting up the role-based access for whoever and the management groups to give you the access. And to you, you're just going to a different web portal than portal.azure.com.
Okay, so considering you have to get new hardware, is that hardware standards for that hardware set through like public RCI RFC, or is it is Microsoft now making hardware specific for the Azure side?
No, so Microsoft isn't making the hardware. We're working together with OEM partners to give you, for lack of a better term, blessed hardware that has all the things that we need, and it's been certified and everything.
Do you know who is in that space?
Yeah, I actually have a slide deck that talks about how to get it and how to, yeah. So,
Looks like then we have to go with those certified partners if
Yes.
we want to.
yeah, but really there's not very many partners who are not certified or have a solution already.
Okay.
Yeah, so it's not like I'm saying it's only the big three. There's other companies that have it too.
Michael, can you please repeat the questions?
Okay, sorry. So as far as who has that hardware and who you can buy it from, it's a number of companies, and I actually have a slide deck that shows you pretty much who's got it. So I just went over that, but it's consistent application development. You can develop one time and have that lifted up into the public clouds. Ideally, we're going to go to Azure, right? Gives you all the services that you're used to. So you have the serverless compute, you have the app service, you have containers, you have the Azure Kubernetes service, you have the marketplace. If this thing has a connection to the internet, it can pull down items from the Azure marketplace that you've chosen and bring it down so that your developers can use it to quick deploy things, right? Virtual machines, networking, storage, and the key vault. So all the same services that you're used to in Azure are hosted in Azure Stack. It's just hosted on premises in your data center, and only for you.
It's something like my own Azure.
It really is. It's your own Azure cloud that you own, right? Now you're paying us for some of the proprietary software with it, right? I'm not saying that you're going to deploy a VM in Azure Stack and you're not going to have a compute cost. You will have a compute cost.
They charge the same way as you go to the cloud.
It's charged very similar, but not as much as what it would be in the public cloud.
Yeah, because you have to put the power. You have to pay for
Right.
the power.
You're paying for the
Okay.
power and everything, and we're paying for the power in our data centers, right? Yeah.
So the question, if you're using Kubernetes in your your on-prem, I know you're Microsoft, but what's the benefit of using Kubernetes for Microsoft than just using Kubernetes on itself?
So, what's the benefit of using Azure Kubernetes over using?
On-prem, in the cloud I get it because
Yeah.
you want to buy resources, servers, that makes perfect sense. On-prem, what's the benefit?
The
Right.
benefit is quick to get started with your quick environment, right? That's what.
Right. Well, I think the benefit for Azure Stack is meant to be that you can develop on premises and running in your internet and have the same services. So if you want to develop things that are using the Azure Kubernetes service, you have a choice of deploying it only in your private cloud, or you have the ability to develop it in Azure. I don't know enough about Kubernetes to honestly give you a great answer on that one. I would have to bring in a developer.
Okay, so maybe a worst case situation. Consider if you have provisioned infrastructure with another public cloud provider like AWS or Google Cloud, and can I deploy Stack there, Azure Stack?
Into AWS.
Because I just taking the systems there, like the only infrastructure as service, like their infrastructure is Google Stack there.
So the thing with Azure Stack is you don't have access to the code to deploy. I can't go and get my own hardware and deploy Azure Stack. Only the OEMs can do that.
So
Because
it's
it,
not there.
yeah, the only thing you could do is a developer kit, and you kind of, yeah, that's kind of like building a submarine inside of an aircraft carrier, right?
It's basically an appliance.
Yeah, it really is kind of, yeah. It's an
The
appliance that
reason-
has Azure.
The reason why I ask this question is consider I am creating Azure functions, okay? And that means I am tightly coupling my code with Microsoft Azure solution. And later I realized the model is not working, so I don't want to rewrite that whole code. So that solution is I'm looking, okay, definitely, because if I don't want to host my code in Azure Cloud, one option is, okay, so I'll have this Azure Stack in my own data center and I'll run. So that is a one-time hardware cost or something. Then because the stack is already there, maybe upgrades keep coming,
Yep.
but everything running in my system. So I need not to worry that, oh, I have to keep paying to Azure Cloud.
Well, even with Azure Stack. So the question is, I can develop the stuff in Azure Stack and not have to worry about ongoing costs, and then I have the ability to move it, right? So yes, that's true. I will say, because I'm not a developer, but I do know the path to going to Azure is much easier from Azure Stack than it would be to go from Azure Stack to AWS or Google Cloud, right? But know that with Azure Stack, it's not just a hardware cost. There is ongoing cost to your apps, your containers, your virtual machines, and your storage that is hosted in the Azure Stack appliance.
Oh, so though everything is hosted in my own data center, still I have to keep paying.
Exactly.
Yeah, you have to pay. It's the equivalent of licensing in that respect, right? Because Microsoft's in the services model now. We're not in the software model, right?
Okay, so it is basically not a solution to have your software written once and use in both, like move away from this kind of.
Well, what it is it's not a solution to say I can buy all of Azure one time and have it in my data center and never have to pay another cent, other than the power to keep it online.
Yeah, it's not like
It's
that.
not that.
Okay.
Yeah, because there's development and future features and things that are coming to
Those are
it,
coming
so it's
to
an
it.
ongoing
It's a cost.
expense, right? But what it's great as is it gives you all the tools of Azure on premises, so you can host it. So if you have sensitive data that you want to run, but you still want cloud apps, Azure Stack's a better solution. We're using it for the Army to deploy Exchange servers in the field. We literally have Azure Stack deployments, rugged Azure Stack deployments in these boxes in the back of a SUV that's being powered by that SUV, and we're deploying Exchange server in the field.
Makes sense.
Yeah.
We have a data warehouse, and our plan is to migrate it up to Azure.
Okay.
Okay? How would this benefit that particular activity or that particular deliverable?
It would only help you. So, how would Azure Stack help you in migrating from your data warehouse to public cloud?
Yeah.
I don't know that I would go that route. I would go with the Azure Site Recovery and Azure Migration route. The only thing it would do is help you speed up your development and keep it in-house, and then you have the option to lift it up later.
It's more like a stepping stone.
Yeah.
You do on-prem, and then when you're ready, you ship it up.
Right, but the thing with Azure Stack is you can continuously develop at a lower cost on premises and do your testing and everything, and then when you're ready to move that app to production into the public cloud, it's just a seamless transition.
All right, but we would still have the overhead or the cost of providing the.
Right. If you want to get
Hardware.
out of owning a data center or, using a colo or anything, Azure
Yeah.
Stack's not a solution for you.
Okay. All right.
Yeah. If
So
you want to
what-
go the Netflix route of no more data centers, right?
Yeah. All right. So you mentioned that there was two things: the Azure.
There's Azure Stack in there. Oh, you're talking about the lift and shift model? So there's Azure Site Recovery, and that would be for traditional infrastructure. And then there's Azure Migration Services.
Are you going to talk about Azure migration services?
I wasn't planning on it. It was another session, but I can.
Pricing for dev mode, there is a cost for dev mode?
No, the dev thing is just completely open to test out and everything.
Test out?
Yeah, and it's running in virtual machines. It does require, I think, 192 gigs of RAM though.
Yeah, kind of.
It's not a small animal in any respect.
Yeah.
You can do it on your laptop.
Yeah, I've tried loading it on my laptop. It really brought me down.
Not gonna work.
I've been looking for service bus emulation,
Yeah.
which they don't have, and so if it was lean, I would just do this, get the service bus. It's free, test that out.
But you have the service bus with the Windows subsystem for Linux.
Yeah, true. But
Yeah. So, what time is it? What am I doing?
You still have 20 minutes.
Okay.
Yeah.
So,
Go back and back.
just want to make sure I'm getting through. So that's Azure Stack. Any more questions on Azure Stack? Well, I got a lot more questions out of some developers.
How
than
do
I
you
thought.
do updates? Let's say, for instance, we used to have document DB and then it became Cosmos DB. How do you handle a major shift like that with Azure Stack? Like, what's the general?
I don't know off the top of my head,
Okay.
to tell you the truth. I'm more in the Azure Stack HCI solution. I understand Azure Stack, but not. I know it's a coordinated effort, and I know it very minimal downtime. So, but the specifics on things like Cosmos DB in there, I don't know that for sure.
Okay.
I can get you the answer though.
I was just curious how you handle like major breaking changes, if,
Yeah.
So like if something changed and you have to have breaking changes to the actual, I guess, PaaS service that's
Right.
running, and how do
Well,
you,
I mean, the thing is with Azure Stack is all your PaaS solutions are still going to have to be developed with availability sets and auto scaling and everything too, because you're not getting out of that. A typical Azure Stack deployment is 4 nodes, right? I think that's the minimum you can actually deploy. So,
And the thing I read blogs about the Azure Stack is that you don't really get to handle the backend, like if you were mentioning about the updates in the backend, Microsoft does that.
yeah. So there are 2 portals into it.
Yeah.
There's one that Microsoft and OEMs can go into, and if you really demand and put your foot down, we might give you access. And then there's the everyday where you should be, and it's similar to the Azure portal. The thing with Azure Stack is there's a middle ground of you've got to control firmware and things like that, and so we have to go through. There's also I'll admit this, in the disconnected scenario where it doesn't have an internet connection, the cost is, there's like 100% cost to it, right, with running the compute, because we don't know how long you're running those virtual machines, where if you're in a connected scenario, we can charge you by the minute for those virtual machines running, right? So, but it still, outweighs. So, Azure Stack HCI, hyper-converged infrastructure, is all the power of Azure, but on premises, but without that Azure Stack part. So you're not going to get the portal with this. You're not going to get the app services, the service bus, any of these things. That's not what Azure Stack HCI is. Azure Stack HCI is a virtualization platform meant for infrastructure as a service. So we see the use for it because your hardware is getting old. It used to be that hardware was like a 3 to 4 year lifespan. Now we're seeing 7 to 9 years lifespan. So we're seeing a trend to go, we need to modernize our hardware. We also want to consolidate our server infrastructure. Right now, if you guys go in your data center, I don't know how many you've looked at a rack, but you'll see usually a couple top of rack switches, physical switches. You might see a SAN appliance with some JBODs, just a bunch of disk drive, right? And then fabric software, and then you have your compute nodes that are usually taking up the bottom half. A whole rack dedicated. We can combine that into a 3 or 4 node infrastructure, even a 2 node infrastructure that runs everything that you want to run, containers or virtual machines, based on Windows Server 2019. And then we can connect to Azure through hybrid features in Windows Admin Center to give you Azure features that you might want. Things like Azure Update, Azure Site Recovery, File Sync, so Azure File Sync. Yeah, it's Azure everything, right? Marketing's put Azure in front of everything, but we'll go, yeah. So this is meant to be a storage solution. If you want to do a disconnected storage solution, a scale-out file server to host SMB storage blobs for your services. So now that containers can talk to SMB now, and then virtual machines, hypervisors, everything can connect to it through there. The other part is remote office, branch office. So this is a huge solution too. This is where that big green P is going. Instead of hosting a SAN appliance and a couple of compute nodes, we're going to host 2 node hyper-converged infrastructure there, where we get rid of the SAN appliance and we make the local disk on our compute nodes into software-defined storage. Right? Business critical infrastructure. So if you have aging infrastructure that cannot be put into a cloud for whatever reason, or it doesn't make any sense because you'd spin through the nose on it no matter what provider you went, you can host it in your private cloud through Azure Stack HCI and have it. And then consolidation, because we're getting rid of half racks worth of hardware and consolidating it, you're reducing your data center footprint and reducing your power consumption and air conditioning. And then we're using it a lot for virtual desktop infrastructure. Though if I was going to do VDI, I'd go PaaS solution in Azure. So Azure Stack HCI gives you the ability to connect to Azure so that you can get hybrid operations. Those hybrid operations are things like Azure Site Recovery, the ability to use Cloud Witness, the ability to use monitoring technology like Azure Monitor, Azure Log Analytics, Sentinel. If you haven't heard of Sentinel now, that is a SIEM provider, which is like Splunk. Backup services. So you can send your backups from your on-premises data center directly up to Azure, stored in a storage blob that you have no access to. Microsoft maintains that storage blob for you. In the case of you get attacked and somebody puts malware on it, we have a copy of your backups that nobody even knows about, right? And so then you request that backup and we give you that copy. And then Azure Update Management, so you can use the same Azure Update Management you're using for your virtual machines in Azure, you can use that on premises. There's also things like Azure Automation, so the desired state configurations you may be using, or the runbooks and automation things that you want, and you're taking advantage of in the cloud, you can actually push down to on-premises through hybrid runbooks and hybrid worker roles. Then we bring in the software-defined infrastructure that we're using in Azure. So I don't know how many of you guys know this, but Windows Server 2008 and 2012 and 2012 R2 were defining what Azure was becoming. In 2016, that flipped. And everything that the Azure team wanted, they were going to the Windows Server team and being like, you guys got to develop this, you guys got to develop this, and we need this feature. All those things then just got rolled into Windows Server and Windows 10. So Azure is defining the path of Windows Server now, and so all those features are being done. So software-defined networking and software-defined storage, like Storage Spaces Direct, are the exact same thing that they're using in the Azure Data Center at a much larger scale. The only difference between an Azure data center and your data center is you have engineers on call and we have developers on call. That's really the only difference. And Hyper-V. Hyper-V is the backbone of what Azure is running off of. And so the scale, if you've ever looked at the scale numbers for what Hyper-V requires, Virtual machines with 24 terabytes of memory and thousands of processors, something you've never actually deployed on premises. That is because of Azure. You got a question? Oh, I thought you were raising your hand.
No, sorry.
No, you're good. You're good. And then we combine it now with the security and management that you have. So Azure Stack HCI is just like Azure Stack in the respect that it's a validated solution that our product group that's running Windows Server has worked with OEMs to provide validated solutions. Basically, you don't have to play the guessing game of, oh, I need these Mellanox network cards to give me RDMA access for the east-west traffic, and I need persistent memory to give me the fastest cache memory. These storage drives, you don't have to play that game. You literally can go to your vendor and say, I want an Azure Stack HCI deployment, and they'll say, what kind of networking, like how fast of networking do you want? And you'll say 10, 25, whatever. And then they'll, okay, how much storage do you want at the end of the day, and things like this, and scale. So these kind of things. So all the things that have been needed to ensure that these are going to run well has been taken care of on our back end. Yeah?
Does this solution allow for controlled release of features, let's say Data Factory? Do you have a switch to turn on certain features or off
So-
as they get released by Microsoft?
So
In other words, it doesn't automatically take effect to determine when you want to put it in.
So the question is, can you turn off or turn on features that are coming from Microsoft for the Azure Stack? So one, I think you are thinking more of Azure Stack and not Azure Stack HCI. Azure Stack HCI is not going to have any of those Azure features like that. Azure Stack, yes, the features are going to come down the pipe and be automatically enabled. You can, as an administrator, go and disable those features. Any other questions? So I'm not in sales, don't think I'm trying to sell you this, but just so you know how to buy it, you buy integrated systems for Azure Stack, and that includes Azure Services on-prem, billed by either your enterprise agreement or your CSP support through Premier. The software-defined infrastructure that we're using in Azure Stack HCI is already deployed in Azure Stack, and then the hardware is something that you purchase from a vendor. It includes the support from us, as always. It includes partner installs on site with the deployment configuration and provisioning, and then your parts and everything are covered through that OEM vendor. Some vendors that do this are things like Fujitsu, HPE, Huawei, Dell EMC, Cisco. Pretty much all the main vendors are doing this, right?
Huawei, I think that's
Huawei, right?
That's banned in the United States.
Is it?
Yeah, the Chinese.
I didn't know it was banned.
Yeah. Yeah.
It,
Okay.
it has happened actually recently with some of
Okay.
the incidents.
Yeah, they had some scandal or something.
Yeah, there were some scandals which.
You gotta think I'm global, so.
Yeah, one of
Okay,
the- one
well,
of
I'll
the
make a
biggest
note of
things
that
was
saying,
in
not in
Canada.
the US, maybe.
Canada actually triggered all of this, right?
Yeah.
It's a big thing.
With Azure Stack HCI, it's a validated solution, so you buy the hardware that you select from your vendor, you actually deploy the software-defined infrastructure. So your engineers will deploy it, versus Azure Stack, the OEM deploys it for you. And then you can optionally turn on Azure Services through Windows Admins. So these are different solutions that offer for Azure Stack HCI. I will make the note about the Chinese company. But if I was to do this, I'd go with Data On personally, but that's not me endorsing them or anything. It's just my own personal experience. Data On makes some really slick stuff for the price. Azure Stack is available in 92 countries. And the main thing I need to tell you is the end of support. So you guys may not be interested in this, but 2008 R2 and SQL 2008 are almost done, right? I think SQL is done in July, and 2008 R2 Windows Server is done in January. So what Microsoft is offering is you can lift your virtual machines and your SQL databases up to Azure, and we will give you 3 years of extended security patching for free. We will also reduce the cost of your virtual machines by 40% if you have a CA agreement with Microsoft, and you turn on hybrid use benefit. So that VM costs you $100 to run a month. With hybrid use, it costs you $60 a month to run. So 3 years of free support. I had one customer who has 28,000 2008 R2 VMs, and in January they're like, "We're going to need to migrate these." And I went, "Yeah, no, we're putting them on Azure, guys. So I'm buying you some time." Right?
That's a bad thing.
Plus Azure and Azure Stack.
Someone needs to pay for that, right?
So the cost savings for the hardware of Azure Stack may make sense because you can extend and not have to buy a very, very costly CSA for your 2008 R2 servers.
You can also move this to Azure.
Yeah.
Get the same benefit.
Exactly. So you don't have to buy the Stack hardware, and you can just lift it up to Azure through Azure Site Recovery or Azure Migration Services. Has anybody heard of Windows Admin Center? Yeah? Are you guys using it?
Trying to deploy.
Oh yeah, it should take you like 5 minutes to deploy.
Yeah.
So I only mentioned Windows Admin Center because I mentioned these hybrid features of Azure Stack. Windows Admin Center, more for your system administrators, server administrators, but this is a web-based tool that is meant to replace all the aging MMC tools that we've used in Windows Server. So things like Server Manager, File Explorer, Active Directory users, computers, Hyper-V Manager, Failover Cluster, all those aging tools that have actually been deprecated since 2008, we just kept limping them along, is now in this web-based tool. And so this tool also is unlocking features in 2016 and 2019 that are exclusive to it. Things like storage migration service. Storage migration services, you have a file server running 2003 or above, and you have not been able to move it because you don't know who's connected to it, who's running a silly little access database on it. So what I can do with storage migration services, I can capture all the files in there, the name, the DNS, the IP address, and shift that over to a 2019 server without my users even knowing it. And then that whole process is reversible too, in case you want to go back. And you see the complete audit trail of what was moved over and things like that. And that's enabled through Windows Admin Center. Features like one-step enablement of Azure Site Recovery. So you don't have to go create a vault and then go through the process of deploying a Microsoft Azure backup service agent and then getting the key and deploying it to your Hyper-V host. With Azure or with Windows Admin Center, you literally connect to Azure and then you say enable this virtual machine for site recovery, and it'll start replicating that virtual machine. If you have to create a point-to-site VPN, that was normally a 90-minute process. We can now create an Azure network adapter on your server and have it have a direct VPN connection to your Azure subscription through a point-to-site. Site-to-site VPN is coming. There are other features like Azure File Sync. Has anybody heard about File Sync? No? Yeah? It's pretty cool. So Azure File Sync is you have your file server on premises. I can install that an agent on there and take all of the files in a particular volume or several volumes and make a copy up in Azure Storage without having to have a server, because I can just use an Azure Storage blob. Works just like a NAS. And then what I can do is I can enable cloud tiering and say, I want 25% of this data to remain on premises and the rest just to be in the cloud. So File Sync will take that bottom 75%, files that haven't been accessed the least, and we'll delete them off your server, and we'll just have pointer files to them in Azure. And it will store the hot data on premises. Your users won't even know unless they're trying to download a 4 terabyte file. But Excel docs and the normal stuff. So it gives you the space back on, and then you have a copy up in Azure. It's domain agnostic, so as you absorb new companies, you can take on their file share, combine them into a storage blob in Azure. It also means if that file server ever dies, all you have to do is build a new file server, install the agent, and boom, within 15 minutes, that hot data is accessible to that server and that share. And your user's completely transparent. I have no idea.
Does it have capability to use express route while it takes the
Yeah, if you want to use ExpressRoute, you can do that.
It's like if it does not, right?
Yeah, I mean, if you're trying to move large files off the ExpressRoute, that's
Yeah,
going
I
to
mean,
be
when
a
you
fun
want to do
experience.
that,
Yeah,
right? The wrong
I put my
answer.
ISOs on it and was doing it through site to site. That was slow, but I knew what I was doing, right? So.
So does it create the Azure resources automatically? Is that what you're saying? For like the VPN and site recovery?
Yeah. Admin Center will automatically create all those in the background for you if you enable those features. New features that are coming, Azure Update support and Azure Monitor through Log Analytics will be tied to the Admin Center as well.
What is the feature name we said for this kind of file transfer?
So that is called Azure File Sync. Very quick, you can deploy that in like 10 minutes. Yeah. Any other questions? That's pretty much what I have for you guys. I don't want to be too salesy, but
That's good.
I was going to show you a demo, but then I added internet access to one of my VMs, and now I can't get on it now. So I got to rebuild it.
Slide where you had the OEMs for the Azure Stack hardware. I'm sorry.
For HCI or Azure Stack? So Azure Stack, the full Azure cloud in your private, that's this one. The one you didn't like, the Chinese company.
Would you like to speak a little about the visualization?
Yeah, do I have time?
Yeah, you can use another 5 minutes.
Okay,
Yeah.
so I don't think I have a deck on it, but
No, that's okay.
yeah. So what do you want to know about Azure Migration Services?
So, like, especially.
1 second. I think she had a question.
Oh, did you have another question? I'm sorry. Oh, okay.
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 Yeah, so, especially like when we are talking about terabytes of data, right?
Right.
Gigabytes, hundreds of gigabytes and terabytes of data. What do you recommend as a migration route to Azure? Like, especially like probably shifting the application. It's all about making changes and moving to cloud, which I feel is easy as compared to moving the data itself to cloud.
Right. So if you're just talking about just file shares and everything like that.
No, we are talking about both. Let's say file share as well as your actual data on SQL servers.
Okay. SQL Server. So Azure Migrate, and I'm telling you guys this ahead of time, but Azure Migrate and Azure Database Migration Tool have always been separate products. They are this summer merging those together. And so in the case of your databases, you want to use the Azure Database Migration Services. What that's going to do is it's going to give you 3 options. You can go to Azure Database as a Service, which is literally you're just hosting an instance on a SQL server that Microsoft is maintaining for you. The second option is you want to control SQL and the VM itself. So you will deploy a virtual machine running Windows Server and deploy SQL on it.
Yeah, let's go to the past route, right?
Well, and there's a third option is managed instance, where you get all the features of running SQL on premises without the operating system. But that is the most expensive.
Expensive one.
The fourth thing is, say you have a non-SQL database. You have Oracle or something else. We can convert Oracle into SQL. We can convert other things into Cosmos DB. I don't know the myriad of things because I'm not a database guy, but we can convert those and send them up to Cosmos DB for an example.
Let's take the case where you want to move SQL Server 2000 to SQL Server 2016 data, right?
Yep.
Into a SQL PaaS instance.
Okay.
Probably.
You would use this tool and you would just say, what is the SQL PaaS instance you want to drop it into? And then it would orchestrate and do a copy over, and then you could do a scheduled cutover. And then in your applications, you would just point, I don't know what that term is you guys use, but point to that database and just seamlessly.
Connection string.
Connection string. Yeah, see, that's an easy one. Yeah. But you would change your connection string. I'll find a YouTube video on it, but literally you do it, and in 2 minutes it's flipped over, and the users didn't even notice.
Does this whole process can use Express Route?
Yes. Absolutely. And if you have a ton of data,
to take a note of this because I'm getting hard time to make people understand that you can do this through Express Route.
yeah, so the main thing you need to know about doing it through ExpressRoute is those ingress and egress charges that we don't charge you normally, you are now absorbing because we don't know how you're doing it. You're routing it through ExpressRoute. Like if you were to do Azure Site Recovery and just back up your virtual machines and send replicas up to Azure, that process of bringing in those terabytes worth of VMs is not charged to you. That's not an ingress and egress charge that we charge you. So you want to recover the VM, no problem. But the minute you start routing it through your Express route, that's going against your Express route ingress and egress charges.
Yeah.
So if you're fine with that, go for it, because that's the fastest way. But if you're doing Azure Site Recovery that normally goes through the internet, it goes directly to us through an encrypted mail. Now, if you have a lot of data several
That's where the
terabytes,
problem is,
you
right?
can use, we have this database ingestion service where you would put it onto hard drives and you would encrypt the data with a storage account name and a storage account key and then ship us those drives. We will put those drives into our servers and import that data for you.
Yeah, the problem with that approach is you need some time to ship it, right?
Yeah.
If I have a business critical application where I cannot have downtime more than 4 hours, then this does not become an option at all.
So there's another option called Azure Storage Replica. And so it's a built-in feature in Windows Server 2016 and 2019. And so you could replicate an entire volume up to Azure, right? And then you can do a cutover after that data. And the initial sync is going to take a long time, and then we're at the mercy of physics in that case, right? 15 millisecond route time, 1,500 kilometer round trip, I think. But once that initial done, then we're just doing deltas going forward. And so we use it typically for data center failovers. Like say I have a Hyper-V cluster in San Francisco, I can replicate that cluster to New York, and if something goes wrong in San Francisco, immediately fail over those virtual machines because I'm using replication across the wide area network through Storage Replica. I'm not a great company that has SAN-to-SAN replication in that case. Right. Make sense? Any other questions? So you can get a hold of me, email me anytime, and if I can't answer your question, I will find somebody who can. I'm not a Microsoft guy who won't answer your questions. So, thanks guys.
Thank you. Michael.Godfrey@Microsoft.com. Yeah, I live in Winter Garden.